Good afternoon, class. So we're going to talk about big data, and we're going to learn about Hadoop today and what is Hadoop and what is the framework for Hadoop. We'll be learning that in this class, and we'll also discuss a real world example at the end of this class. And we'll go with advanced Hadoop topics in the next class. Okay. Let's start with what is the big data. Before we start with big data and before we start with the class, let me share my screen and we can go over the presentation. Just give me a second. I'm going to start the slideshow. So how's everyone doing in the class today? Good, good. It's really nice to hear. Okay, let's talk about Hadoop basics. That's what we're going to talk about today, right? So I'm just going to go over this. I just told you about the agenda, right? So the agenda for today's class is going to be overview of the Hadoop system, overview of big data, Hadoop. And we're going to talk about what is a distributed file system, right? So whenever you see Hadoop, you'll see HDFS. You want to see what the DFS means and why the DFS is there and why is it so important. We are also going to go over the high-level architecture of Hadoop, go through different components of Hadoop, understand what each different components means and how it is used. And we are going to look at one of the components, that is the storage component, in a very detailed way in this class. So rest of the components we'll be covering in the next class, and we will also go through a use case. I think I kind of missed out the case there. So we are also going to go through a use case and go through the real world use case of Hadoop and try to understand how Hadoop is being used in the real world. Okay. Let's talk about big data. Whenever we talk about Hadoop, right, we always think immediately about big data. What is big data and why is it so important? We keep hearing about big data wherever we go in any industry, whether you are just starting out, getting out for a job, or you're just you're an experienced person in the IT field. You still always, it doesn't matter IT, it's anywhere you go, the big data is going to be a very huge concept for you, understanding big data, what it means, right? So every day, massive amounts of data is being generated, especially in today's world. You see, we have almost such kind of media or such kind of devices that generate so much of information every minute, right? Whether it be your just basic, your, let's say you have a cell phone, right? Your smartphone, whether it is your smartphone or where you're using your laptop or you're going online using some app, or you're going purchasing an insurance or insurance industry, finance, banking, whether you go to open a bank account, you provide the authorization, how the authorizations are stored, how it will be retrieved, for how many years it needs to be stored, and how it will be processed. There are a lot of things that's there, right, when the data is being generated. So in earlier days, we didn't have so much of information. Most of our work was done on paper and files. So most of them were stored in paper and files. In fact, like back in, I think 80s, I would say, or even in 90s, right? Even up to early 90s, I would say, even universities, they stored their degrees, mark sheets, and everything was there. Even licensing was different. Nothing was as digitized as today. So today, a single piece of card can generate so much of information, or a single piece of everywhere you go, right? For example, you go into any stores, you always have some kind of a rewards program in the store. They give you some kind of identity that you can swipe, or you enter your phone number, it generates that. So that's kind of generating some kind of data, right? So the summary is there's a lot of data that is being generated today. And like I said, cell phones, almost everybody uses the smartphone, right? So they have pictures, they have text, they have chats, and they've got so many apps, and you download movies and you go take nice pictures. Maybe you're creating a travelogue and you want to use your phone, you find something really good, you want to take a video of it and post it on social media. So many different forms of data you're using today. And also, social media is a very good example of generating massive amounts of data. Twitter, you take Facebook. There's so much amount of information that is going into Facebook that needs to be processed, right? So just imagine like maybe millions of people, if not billions of people, they use Facebook and they go ahead and they do this uh, some activity. Maybe they're uploading a picture, maybe they're trying to start a log, or they just want to share something. So much amount of data is being generated. So all this massive amounts of data that cannot be processed in a traditional way. When it's a traditional way, we can, I'm talking about like a single storage, right? You have a single storage, you have single piece of storage, and you just go ahead, store all the data in there and try to retrieve it, just like you have you got in laptop. Even in laptops, you see nowadays you got 1 terabyte storage is available in laptop. And earlier days, it was considered to be a very huge amount of data, 1 terabyte, because there were not enough devices that were generating this kind of data. And frankly, even the internet has contributed a lot to this, because of creating a website, doing stuff now has become so easy with cloud computing and other advanced mechanisms. So the amount of data that is being generated is so huge that could not be processed locally, or that could not be processed by storing in a single storage area. Also, that could not be processed, it's processing serially. So as the data comes in, if I take each data and start processing it, it might take maybe, I would say, years and years to kind of go ahead and process all the data we have, and still we might not be able to get to the end of it. So what is happening here is so there was a need that created a need for handling this huge amounts of data. This huge amount of data that I'm referring to is called as a big data, right? So how do we classify big data? So, okay, it sounds good when you say huge amount of data, but how do I classify a big data? What are the attributes that will make it a big data, right? Let's talk about that quickly. Volume. Volume is one of the things. So how much of data is being processed? How much of data needs to be processed? So is it a peta-sized data, exabytes worth of data, or zettabytes worth of data? So earlier information we spoke about, right, about cell phones. Easily one person can generate, I would say, like 50, 60 exabytes of data from one cell phone, right? Just one smartphone user can generate 50, 60 exabytes of data per month. So you can imagine how much of data will be there when we combine all the users. So that is the volume of the data, huge volumes of data. Okay. Next comes the velocity. What is velocity? Velocity means the speed at which the data is being generated. How much data is being generated per hour, how much data is generated per second, how much data is generated per minute. The speed with which the data is getting generated is called the velocity of the data. So that is also very important, because the speed of the data is being generated very fast. We need to have a capacity to process them really fast. Otherwise, all the data will get accumulated, and we will not be able to process all the data in time for it to make it useful. Okay. Next comes the variety of data. When we talk about the variety of data, what is the variety of data, right? So when you say variety of the data comes in different forms, right? You've got let's say you got a picture that is in a JPEG file, right? And then you got a video, and you have an Excel spreadsheet document that you've been working on. You're trying to upload that, and then you got, let's say, some log files, right? From your system, maybe your system is generating some log files, and you're just looking at the log files. So there are different kinds of data, different formats of data. What happens is this formats of data are divided into three major data classification. One is structured data, then the other one is semi-structured data, and finally is unstructured data. So even your emails, right? You got a lot of email going. If you see Gmail, you got, even one person has got so many Gmails open, right? So you will have so much of Gmail data or email data being generated. So they need to be stored and processed in a very timely manner. So the three types of data are the three varieties of data, right? Structured, semi-structured, and unstructured data. We should be able to process all three of them. These are the three big data, right? So this comprises the big data. Next, we are going to talk about the veracity. Veracity is kind of a little bit, it's kind of a little bit different term because veracity is more like an authenticity of the data, or let's say I wouldn't say the type, it's the accuracy of the data, right? The accuracy of data, the authenticity of the data, or the truthfulness of the data. So this is the veracity is actually going more like a, let's talks about the data quality. How good is the data? How accurate is the data? So again, if you take any social media platform or anything, so people are able to do different kinds of things on there, right? So let's say they put in some special characters. It should be able to handle the special characters. Again, the languages are different, right? Each language is different. So they have different kinds of alphabets that needs to be accommodated. So how do we handle all this data? So the veracity of the data means the truthfulness or the accuracy of the data. Okay, and just remember it pertains to data quality. I'm not going to go very detailed into the big data stuff, because we are going to talk about big data in later again in one of the classes in a very detailed way. So big data is also going to be a part, but we're going to go a little bit detailed, in much more detail than that. Here we just want to know what is a big data, how do we classify it, and why it is so important. Value, what is the value? When you say value, right, big data needs to generate all this data processing at the end. It has to generate some value. It can be a monetary value, it can be information value. All this needs to happen, because if there is no value, there is no point in doing all this, right? So there has to be a value in processing and storing the data. That value is what is the value that you're deriving. Here we have given an example of monetary, research, and social. So monetary obviously means we're going to use it for, it's going to gain us some benefits and dollar amounts. And then research is basically just for analytics. So you want to do a marketing strategy, you want to analyze the data, right? So something like that, research. Because there's also some social reasons that we can use this data for, could have some social values. So we saw about the big data now. Any questions on the big data so far? Good, Sam. That was a good one. So I'm glad that you guys have understood this big data. So we'll go ahead, we'll focus, our main focus is going to be on Hadoop. So we are going to talk about Hadoop. This is what the focus of our course is going to be. And we're going to talk about the Hadoop and how it is used in real world. What is Hadoop? What is the structure? How do we implement it? We're going to go into very detailed into Hadoop. Okay. So what is Hadoop? So now you saw this huge big data, right? So you've got massive amounts of data you want to process. How do you process all this massive amounts of data? So what we do is basically we'll go ahead. We need to have some kind of framework to process all this massive amounts of data. So this massive amounts of data is, the Hadoop is just another framework for storing and processing this massive amounts of data efficiently. It's a framework specifically built for big data, so that if you have any big data challenges. So I have not spoken about the big data challenge. I think I spoke about it, but I've not explicitly said it. So the big data challenges are going to be mainly storage. If you have a lot of amounts of storage, right, lots of amounts of data, you can't store it in a single storage unit and try to retrieve it, right? It's going to be very inefficient. It's going to be time consuming, and you'll have very difficult time handling or processing this data. Second one I spoke about is the serial processing. Serial processing is going to be very difficult because you will never get to the data in time, and data also, like everything else, loses value over time. If you are not able to process the data in time, a time and meaningful way, then there is no way that it's going to add to any value. And of course, the last one is the ability to add unstructured data. So unstructured data is very difficult to process, store, retrieve, do all those kind of things, because it is basically unstructured. There is no traditional way. There are traditional ways, but it's more difficult and more expensive to process those through those channels. Okay. So Hadoop solves all these challenges. It offers distributed storage, it offers parallel processing, and it can handle every type of data. So that is the big thing with the Hadoop. Okay, we're going to go and talk a little bit about the three components of the Hadoop. So what is the other systems that comprise of Hadoop ecosystem? One is Pig, Hive, and Spark. I'm not going to go into any of these things because it might throw you off. So what we'll do is we'll just focus on Hadoop and the three components. What the intention of this class is for you to understand the Hadoop architecture very well, know how Hadoop works under the hood. So you should be able to know what's happening behind the scenes when you're writing any piece of code. Okay. I will also go into Hadoop clusters in advanced classes and see how the clusters are stood up, what happens, how they process. Okay. Let's talk about three components. One is storage. Like I said, storage, it's a distributed storage. I will show you what a distributed storage is and what it means. And the processing is done by MapReduce. We'll talk about MapReduce, and we'll also see what are the benefits of MapReduce, how we are going to use it. And Yarn is a resource manager. So basically, Yarn is yet another resource negotiator. It contains resource manager, node manager, application manager, and containers. Okay, we'll go into detail in all three of these components to understand the Hadoop architecture. So distributed file system. What is a distributed file system? Okay, here you see the two file systems. One is a local file system. You can think of your laptop as a local file system, right? So you have just one laptop, you have a hard drive sitting inside it, and you just store all your files on that hard drive, create folders, and you retrieve it. But in real world, if you have massive amounts of data, that is not going to be efficient at all, okay? Because it's going to take a lot of time for you to retrieve the data and process the data. Also, it's going to be very difficult to store all this different types of data, different varieties of data. Like I said, maybe like email, you've got spreadsheets, you've got documents, you've got logs, I got pictures. So saving all those things is going to be a little bit difficult, and retrieving them and processing them is going to be very, very, very difficult, if not very, very, very expensive in a local file system. Okay. Also, there is no what we will call as a what happens if the local file system breaks, or if your hard disk goes bad, right? Your data is lost, which is also again another risk. Then if you need to replicate it, then you'll have to have another disk and then work out some kind of mechanism, which is going to be time consuming. Again, it's going to be almost impossible to do. So let's talk about this distributed file system. Distributed file system is having this data distributed over multiple servers, multiple storage units. So here you see you have 40 terabytes of data, right? Instead of sitting it in one place, we're going to have four storage units, each of 10 terabytes of data. So you have 40 terabytes of data, but that is distributed. So there is not in a single storage unit. It is distributed across multiple storage units. So that it can be retrieved, and then more efficiently, it can be processed more efficiently. It gives you the ability to efficiently store this data. Okay. Any questions so far? Thanks, Abhinav. I think you are absolutely right. And we'll go a little bit more detailed in that in the next class. Okay. So what is Hadoop file system storage? So this is the structure of Hadoop file system, right? So we're going to talk about the storage unit. How does it work? You have this data nodes and you have this name nodes. So it's kind of like a master-slave relationships. Any of you guys who have done some kind of computer engineering background, you'll understand what the how the master-slave architecture works. One of the good things about this is there is also this, if you see this, there is a name node. Name node is kind of where all the metadata is contained. So it just contains again, when I say metadata, what is metadata? Yes, you're right, Rajesh. So metadata is data about data. Basically, whatever storage, whatever the name, and we got the replicas, and whatever the path, etc. So it contains the data about that storage where we are storing the data. What is the path to the data? How many replicas, etc. Right. So name node contains all this information. And then you also have something called as a data nodes. Data nodes is where actually the data is being stored. So if you see here, there are multiple data nodes in rack 1, and then in rack 2 is what we need to talk about. That is what uh, talks about the replication. Why is replication important? Because if you see, if you have a data, let's say you don't have replication at all, right? Then what is going to happen? So suddenly, let's say one of the data nodes goes bad, and we don't have the ability to read from the data node anymore, which means you've got lost the data. Your data is not recoverable, and it has become corrupt. So we cannot retrieve the data. The data is no more useful for us. To avoid all that, we have a replication of the data. Right? Hadoop provides this ability for replication of the data. It does a 3x replication. That what that really means is it kind of going to replicate it in 3 different data nodes. Instead of 1, it's going to go to 3. Okay, each data is being replicated 3 times. So your data is secure and safe. Yes, Rajesh. Yes, you're right. So you have got the name node, which is uh, metadata, and you have got the data nodes, which is where the actual data is being stored. Okay, and you also have a replication for this. This is a 3x replication, like I said. So you'll have a 3x replication for this. Okay. Any questions on this? We will go into this in a very detailed way in the next class. This is just a high level class. We're going to go a little bit of detail, not so much of detail. We'll go into very detailed, and we'll also look at what is map reduce, how map reduce works, and then we'll go ahead and also look at the final output and how it looks. Okay, we'll take a real world example and do that. Any questions so far? Okay, so let's go ahead and let's proceed with our slide to the next